Do you hear me?
Yes.
I've been talking about uh, the equation of motion. What was the equation of motion? Again, uh, if you remember, I talked about this system. We have a mass, spring, and damper. If you remember, I told you that each of these parts, um, or each of these parts represents a system, an item in the building. For example, the mass represents the heavy floors and roofs. K or springs represents, for example, columns and walls. Dampers represent the systems inside the building that can absorb energy. And because this system is complicated, we neglect this one and we consider this. Um,
Sir, can you speak a bit louder?
um, as I said, each of these items represents an item in building. This one, mass, represents weight of the floor and roofs. Spring represents columns or walls, shear walls, pieces. Um, C or damper represents mechanisms inside the building that can absorb energy, such as, if you remember, such as infields. Infield, infields. What does it mean? Anything that fills inside the columns. These infields can be bricks. Okay, for example, here, bricks fill this empty space. Sometimes they are block, sometimes they are whatever, woods, whatever. So we call them infields. One of the mechanisms that can absorb energy, and damper represents this system, whatever. So we consider this system, and we can in simple buildings. Not, for example, as I said, for complicated buildings, we're not going to use this, or we have different methods. But here, because we should know the simplest system first, then we can go further and make them complicated. So for this one, if you remember, I told you that we need to find free body diagram. And by using free body diagram, we can develop equation of motion. For this system, M, if we have a force P in this way, for example, this is positive x, and this is negative x. Okay, we have Fs.
Sir, I don't know. Sir,
You don't know?
your screen freeze. I can't see anything.
You can't see my screen?
Yes.
Is it better now? Can you see the screen now?
Okay.
So here we have three forces. One of them is P, one of them is Fs, the other one is for a damper or Fc or Fb. Okay. If we want to find the response of the structure, what is the response? For example, you have a force here, earthquake force, and if I ask you to find the displacement of the structure, for example, after the earthquake, you have a displacement like this. If I ask to find the response of the structure, you should find this displacement, or you should find the velocity, or you should find the acceleration. Okay, we call these type of items or we categorize these items as the response of the structure. So, as I said, in here we have another force, inertia or inertia, because of the movement or the motion of the mass. E is equal to Fs plus Fd. Okay, we have another force Fi, inertia, because of this one. What does it mean? That means when you move this, mass, uh, we have ground and ground acceleration. Let me explain from the beginning. This is our structure. This is the shaking of the ground because of the earthquake. And this is the weight, and we show it with a lumped mass. So, because of the earthquake, this mass shakes. And we have in this shaking, or the reason for this shaking, is a force equal to mAg, the weight dot ground acceleration. Because of this shaking, we have three things. One of them is displacement, one of them is velocity, and the other one is acceleration. The force inside the damper triggers with velocity. This one, inertia, I think you know it from the physics, triggers with acceleration, and this one triggers with displacement. Okay, so if I push, assume that this is P, if I push this weight with a force P, this force, uh, this action has a couple of reactions, such as this one, because of this the stiffness, this one because of damper, and one of them is Fi because of the inertia or the weight or the mass of M. And in the other side we have P. So if we wrote the equation of motion, sigma Fx equals 0, we would have P in the other side, and in this side Fs plus Ft plus Fi. Okay, what is Fs? Fs, I talked about it, is k dot x, like a spring. Damper, the force inside damper with a coefficient of c triggers with speed or velocity. Fd is equal to what? C dot v, or velocity. And because of the inertia, second law of Newton, Fi is equal to m dot a, acceleration. Okay. So if I want to write this equation again, in one side we have m ag, in the other side we have what is Fs, k dot x plus, in this one c dot v plus m dot a. Okay, this is the coefficient of stiffness, this is the coefficient of or the damping coefficient, and this one is the mass. So stiffness, damping, and mass. Okay, I know this might be a little complicated because it's the first time that you hear this, uh, but I just need you to know the general concept. I'm not gonna give you uh, examples of problems to solve or to use this. I just need you to know the general concept of equation of motion. So again,
There, there is problem again in the screen.
yeah,
Only Fs and Fd. Okay, see equations you wrote.
okay. Can you see it now?
No.
No? What now?
No.
Maybe you should, I don't know, let me leave and join again. still low?
Yes.
Can you see or not?
No, I can't see.
Okay, leave and join again. Leave the meeting and join again. Mustafa, can you see this screen?
Yes, sir, I can.
Where are you?
What?
Where are you?
Your voice is very loud.
I said, where are you? In your country or in
I think I have a bad connection. That's why
No,
your
I
voice
said
is.
where are you now?
Now I can hear you. I am here, teacher, but the problem that I
I know,
was.
I said in which country? Your country or in
Yes, in my country, in my country.
You're in Iraq?
Yeah, yeah.
Okay,
What about you?
I'm in my country. Charlotte, can you see it? Mustafa, mute your voice.
Okay.
Uh, can you see it now?
Yes.
Okay. Um, as I said, um, when we want to find the equation of motion, uh, we have to use free body diagram like this, and then by using this is not zero, sorry. Sigma of x is not zero here. I made a mistake. Sigma fx is equal to p, not zero, because it's not static.
Yes.
And by using this equation, you can derive this one. And I explain that. So just for your information, if, for example, if I give you shape, system, you just need to any system, for example, something like this. You just need to find the force and um, write the equation of motion. Just it's just for your information because you should know uh, partial differential equations to solve them, and I think you don't. So I'm not gonna go through this. Uh, one of the things about the earthquake is non-structural earthquake phenomena. Non-structural earthquake phenomena. What does it mean? If we have a structure like a building, when we investigate, when we evaluate this structure within the earthquake, we say that this is a structural investigation. Okay, for example, bridges, buildings, roads like this. But the ground, rivers, mountains, they are non-structural elements. Okay, so this is building, bridges, everything that we build. Okay, they are structural elements, but such as, for example, something such as rivers, or for example, mountains. Okay, for example, you have a mountain here. If we investigate uh, this mountain after the earthquake, we say non-structural investigation. For example, after the earthquakes, we may have rock falling because of the shaking. Couple of rocks fall down the mountain. Okay, or for example, because of the earthquake, the water inside the ground, uh, the water inside the ground gets out. Okay, because of the pressures. So they are non-structural earthquake phenomena. So in this chapter, we're gonna talk about these non-structural phenomena. The first one is landslide. The second one is graben. The third one is rockfall. Fourth one, slumping. Fifth one, liquefaction. Sixth one, change in water table. Seventh one, tsunami. Okay, so what are they again? They are non-structural. Earthquake, uh, okay. As I said, for example, after the earthquake, we have, for example, after the earthquake, we may have a collapse or a failure in one of the columns, or in one of the beams, or in braces, or in walls. All of them are structural. But if we talk about the rivers, mountains, water tables, seas, oceans, all of them, they are non-structural. Now I'm going to explain each of these uh, phenomena. The first one is landslide. In the landslide, a part of the ground, a part of the earth, slides to uh, or yes, a part of the ground uh, slides down. For example, this one slides down, and after the earthquake, we have such thing. Okay, we can say that. Before that, for example, here we have a road, we have a street, we have whatever, uh, and after that we have something like this. What are they? They are part of the ground. They are the, for example, soil, mud. Okay, so a part of the earth, a part of the ground, slides down. Why? For what reason? Mainly when we have water inside the soil. Okay, water inside the soil. So let me write it down so you can uh, landslide when part of the ground slide down because of the earthquake. Okay, and the main reason is water or penetrating penetration of water inside the soil. It's obvious. For example, you all know that F is equal to ma. For example, in one case, we have this soil and this is dry. For example, with gamma of 16. In the second case, we have this one. For example, here we have saturated soil. Okay, in this case, we have saturated soil. And if you check, you'll see that the saturated gamma is, for example, 22. Okay, so why, for example, here uh, we have this soil, and after a heavy raining, for example, because of the rain, the water penetrates inside the soil. Okay, the water drops penetrate inside the soil and increase the weight of the soil. So in this, in first case, for example, we have the weight of M1. So here we have F1. A is constant, earthquake is constant. And in the other case, we have M2.8. Because M2 is more than M1 because of the water effect, F2 is more than F1. So if you see that, for example, we have a stable soil, but after a heavy rain with a small trigger such as earthquake, this part that is the heaviest part, because here we have uh, less uh, support than the other one, the other part. Okay, so we'll have landslide like this. I don't remember. I remember that, for example, last year when I was in one of your classes, one of the roads near Baku had this situation, had landslide because of the rain. And I don't remember which part. I think it was BB or something like that. If you remember, you had a landslide. Why? Because of the raining increase the weight of the soil and by a small shaking. For example, if you have such thing, for example, this is a road, okay, and this is a slope. When you have cars, for example, or when you have, for example, constructions, the movement of the cars create shaking, small shaking. You sometimes you feel it because of, for example, passing a heavy truck. You shake. Okay, So earthquake is a shaking too. So sometimes we have natural shaking such as earthquake, and sometimes we have artificial such as passing a truck, such as moving a truck. In all the cases, the shaking triggers the water inside here. Maybe in some cases it's not water. Sometimes it's a loose soil. But in most of the cases, we have water inside this soil. So we have landslide. Okay, we call this landslide. The second one, or I should tell you how to prevent from landslide. To prevent or to avoid landsliding, A. You can use retaining wall. What is this retaining wall? For example, you have slopes, and because you and here you have a slope, you have a mountain, you have a hill, whatever, and here you have a road. Okay, and if uh, if landslides happen here, you'll have problem with this road. So you can use a retaining wall in the places, in the locations that are important for you. What are retaining walls? For example, you build just a wall here, and if uh, landslide happens, the soils will be here. So you won't have any problem with the road. So the first method to avoid landsliding is retaining wall. The second one is sheet pile, or the second one is sheet piling. We have some sheets like this. Okay, and if we put these sheets, okay, inside the loose part, we can prevent from landsliding. How? For example, I know that this part of the sound, this part, in this part we have loose sound, a loose sand or loose soil. So I'll put these piles inside this ground so I can prevent from landsliding. So the second method is using sheet pile. Is to use sheet pile. The third one is using an or anchoring. For example, we have this type of soil here again, and I know that this soil the soil here is loose, so I'm gonna put some anchor like this. You know what's anchor? We have, for example, line, nails, line rods. We drill these rods, these nails inside the soil so we can strengthen the soil here. Okay, so the last method is draining. Draining. What is draining? As I said, for example, this is the soil, and because of the water inside the soil, the potential for landsliding increases. So if I want to reduce if I want to reduce the risk of landsliding, the other method is to drain the water inside the soil. What does it mean? It means, for example, if I provide some piles inside the soil, the water would drain and get out. Okay, small drains. For example, I think you saw the many drain system. For example, beside your streets, we have a drainage system. For example, this is the street. We have some places for passing water. Okay, this is a drainage system, and if we provide a reasonable slope inside the uh, along the street, so the water would move to this draining system. Uh, any problem? Any question about this part? Landsliding.
No.
Okay, is it clear? Okay, so uh, they are the ways to avoid landsliding. And the problems that happen because of landslide is obvious. Okay, for example,
So will you upload this recording to YouTube channel?
yes, yes, yes. Um,
Okay.
for example, if we have a landslide here, the main problem with this landslide is, for example, we have many failures, many we would have many failures in this part, in downstream. Okay, for example, sometimes we may have a village here. Sometimes we may have a road. Okay, so because of this landslide, all of them uh, would disappear. Okay, the second one is graben. The second one is graben. What is graben? For example, you have earth. This is your ground surface, and because of the earthquake, you may have a wake like this. So this is the ground surface before the earthquake. and this is the ground surface after the earthquake. We have failure surfaces here, and the reason for this failure is earthquake. But the thing about this type of failure is that the shape of this settlement, and here we have a specific type of settlement. This shape would be like a wedge. Okay, so whenever you have a wedge-like settlement, because of the earthquake, we called it graben. Okay, again, we have a settlement type, a settlement like a wedge, shape with the shape of the wedge. So what's gonna happen after? Let me write again. For example, this is the ground, and this is the settlement. So what's gonna happen after this problem, or after this event? If we have, for example, at the first before the earthquake, this was the ground, and we had a building here. Okay, but after the earthquake, for example, the building would be like this, and this is a failure. So the main problem is that the structures that are on the boundaries of graben will collapse like this. One of the main structures, for example, you may have buildings, you may have uh, bridges, you may have pipes. This is the main problem, pipes, pipelines. For example, oil pipes, sometimes they are, uh, their length is more than kilometers, 10 kilometers, I don't know, 100 kilometers. So, for example, you have a pipeline system, water, oil, sewer, and suddenly, because they're inside the ground, okay, and because of this settlement, you may have, for example, failure like this, and you have many problems after this. For example, you have the seepage, you have the seepage of, I don't know, water, sewer. Sometimes they are toxic materials. Sometimes they are dangerous. Sometimes they are flammable. And for example, sometimes this is the only pipes for transmitting water. Okay, so the water of a village will uh, face problem. So The main problem is with the structures that are in here. And it is obvious we can't do not anything, but we can't control this, this phenomenon from happening. Okay, in some cases we can uh, compact the soil here. Okay, we can compact the soil here, but in most of the cases we can't do any effective thing here. The third one is rock falling. Falling down of rock pieces from mountains or hills. It is obvious. For example, we have a mountain, and because of the shakings, we may have cracks, small cracks, and because of, for example, freezing and heating, we may have cracks inside the rocks, and then by shaking, these parts may fall down. So we call this rock fall. And it's obvious that we may have problem with the parts that are down the road. Sometimes we have a bullet here, sometimes we have a road. Uh, Cars, trucks are in danger because of this phenomenon. Okay, we have a couple of methods to prevent from rock falling. The first one is to find high risk areas and remove remove cracked rocks by our own. How? What does it mean? For example, you can find the places that we have the potential for rock falling, and then remove this. For example, by hammer, we can remove it by our own, and by secure the place. So then the potential or the risk of this rock falling reduces. The second one is injecting or injection of like strengthening the rock by injecting haste. And what does it mean? For example, it's something like, for example, glue. Okay. For example, you know that this area has a potential for rock falling. So you can inject growth, for example. You can inject, I don't know, cement paste. You can inject a couple of materials so you can strengthen this rocks. The other method that I explained for landsliding, if you remember, I told you anchorage, anchoring. The third one is using anchors. And so you can tie the rock with anchors. Okay, that's enough for today. I'm gonna upload the video on YouTube right now. So if you want, you can tell me. Do you have any question?
No, sir.
Okay, see you.
See you.